Good morning, my lovely students. I welcome you to this wonderful online class. How have you been coping with the classes? I hope you are finding them interesting. Okay, right about now, what you have is basic technology. This class is for JSS 3. Your topic is basic electronic components. And your subtopic for today is resistors. I remain your lovely teacher, Mr. Samson. Okay, remember that all this while we've been talking about basic electronic components. Basic electronic components. And this has actually opened our eyes to see some of the components that are found in our electronic devices at home, your television, your radio, your torchlight batteries, your standing fan, yes, your DVD, and the rest of them. Okay, all these things we have been discussing, they are all found in those your electronic components or electronic devices at home. And by now you have known the function of many of them. Okay, I'm not going to waste our time to go back to where we started. Maybe vacuum tube, electronic valve, diode, triode, what's the other one? Okay, gas discharge tube, transistors, integrated circuits, oscillators, and the rest of them. Okay, last week we talked about oscillators and the electronic circuits. We also looked at semiconductors and the rest of them. But today we'll continue because we have other new topics, new electronic components that we have not talked about, and one of them is a resistor. It is a very vital component of electronic devices. A very vital. There is no hardly will you see electronic device that doesn't have resistors in them. Resistors, not just one, not just two. Why? Because resistors, apart from even regulating current that enters the entire circuit, entire board, resistors also regulate the amount of current that enters individual other components that you have there. Okay, because you know that all those components that were mentioned, they are connected to current, to source of current. Current pass through them or current enters them, which makes them to perform their function. Okay, now in each of these, some of them they have to have resistor attached to them in order to regulate the amount of voltage or the amount of current, electric current, that will enter them. I don't know whether you are getting this thing now. So if a particular gadget or a particular component, okay, or let's say an IC, integrated circuit, is designated to carry only a current of about 1 ampere, and the current flowing in the entire circuit is up to 3 amperes. Remember that current is measured in ampere. Okay, amps. Okay, so if the current flowing in the entire board is 3 amperes and one IC require only 1 amperes to function normal, what do you do in order to make sure that the 3 amperes will not damage the IC? You have to introduce a resistor. Have you seen the reason why resistor is very, very important in electronic components? All right, so now let's see what we're talking about. Resistors. This is another circuit component which converts electrical energy to heat energy. Take note how it works. How does it work? It will collect part of those, the extra voltage or extra current and convert it to heat. When it converts it to heat, it will dissipate it outside to the surrounding. Are you getting it? That is why some of the gadgets you use, the back, when you touch the back or you touch the body will be warmed, the body will be hot. What happens? Excess electrical energy is being converted to heat energy and then dissipated to the surrounding. That's just what happens there. I am going higher and deeper because you are already in JSS 3. Okay, it's no longer, you did this topic in JSS 1, but we just touched a little part of it based on your syllabus or scheme of work. All right, but this time around we have to dig deeper and see how these things work. We say that it converts electric energy into heat energy. Now I've told you that if an IC requires only 1 ampere to work, and in that circuit or motherboard you have up to 3 amperes, what will you do? You will use a resistor to convert the remaining 2. 2 is already in excess. 2 amperes are already in excess. So you use a resistor to convert the excess current into heat and dissipate them to the surrounding, to the outside of the circuit. So to allow only 1 ampere enter into the IC, the integrated circuit. We say that it checkmate the flow of voltage from one component or to the other, or the voltage entering the entire circuit. A resistor is a passive 2-terminal electrical component that implements electrical resistance as a circuit element. Now, it's a passive 2-terminal. 2-terminal means that it has 2 legs, one for entering, one for leaving. Do you understand that now? One where you connect the current, the wire, and then the other one is for leaving, where the current escapes from it. Okay, so it's a passive. Passive means that it doesn't have electric current of its own. It receives from the source. Okay, now let's look at the uses of resistors. In electric circuits, resistors are used to reduce current flow. 1, to reduce current flow. Number 2, adjust signal levels. It may be electromagnetic signal level, it may be electrical signal level. To divide voltages. Are you getting it? This one now, to divide voltages. Okay, number 3, to bias active elements like your transistors. Your transistors can be biased. Are you getting it? Or when you some of you that will do physics, you know more about this. And to terminate transmission lines. So resistors can be used to stop flow, stop flow of current and bring it to a stop, among other uses. There are many other uses of resistors. High power resistor can dissipate many watts of electrical power as heat. May be used as part of motor controls and power distribution system, or as test loads for generators. Now, this brings us to types of resistors. I hope you are following. We have 2 major types of resistors. 2 major types. We have several other types of resistors, but I'm going to talk about 2 major types. These 2 major types are, number 1 is fixed resistors. Fixed resistors. These have resistance, or resistances that only change slightly with temperature, time, or operating voltage. So this, in the case of fixed resistors, the resistance change slightly, just a little, with the change in temperature, with the change in time, or with the amount of voltage. Are you getting it? Now the second one, we have the variable resistors. In the case of variable resistors, this one is designed, it is designed so that you can use it to adjust circuit elements or circuit parameters, as I'm going to mention them now, such as volume. In the case of your home theater, you can use variable, what they use to control the volume. If you want to increase the volume, if you want to reduce the volume, is variable resistor. Or your lamp, that the bulb is shining bright or that it is shining very dim, is controlled by variable resistor. As a sensing devices for heat, okay, in the case of your thermostats, okay, or light, humidity, force, or other chemical activities. So these are the two basic types of resistors. Okay, we want to look at the composition. What is it made up of? This resistor we are hearing. Other ones, we looked at them, we saw what they are made up of. Transistors made up of 3 terminals, okay, the base, do you still remember, the collector and the emitters. Okay, but this one now, we're going to look at what they are made of. Okay, resistors can be constructed out of variety of materials, different materials. Most common is in the case of modern resistors are carbon, metal, or metal oxide film. In these resistors, a thin film of conductive, that's though still resistive materials, is wrapped in a helix around and covered by an insulating material. Okay, most of the standard no-phase through-hole resistors will come in a carbon film or metal film composition. What's it made up of? Okay, your carbon, your metal, or metal oxide film. All right, now we also have other through-hole resistors. Through-hole, that's the one that you pierce, you pierce your motherboard, and then it comes out to the back of it. You see, might be wire wound or made of super thin metallic foil. These resistors are usually more expensive. High-end components specifically chosen for their unique characteristics, such as higher power rating. They have the ability to stand a higher power or higher voltage, or maximum temperature range. I believe you understand that. Okay, then we also have surface mount resistors. I've talked about 2 different types of resistors more, apart from fixed and variable. One I talked about, the through-hole resistor, and then this is another one now, surface mount resistors, usually thick or thin film variety. The thick film is usually cheaper but less precise than thin. Okay, all these things, they come with calculated power or calculated rates. When you want to design, you go there, you say, once you say give me a resistor, they will ask you what is the capacity. You'll be able to tell them the capacity. In both resistor types, small film of resistive metal alloy is sandwiched between a ceramic base and glass or epoxy coating, and then connected to the terminating conductive edges. All right, now I want to talk about the units of resistors. Resistor is measured in resistance. Okay, how do you measure a resistor? Resistor is measured in resistance. So you can now say the resistance of the resistor. That's the ability of the resistor to resist, is what we call resistance. So the electrical resistance of a resistor is measured in ohms. Is measured in what? Ohms. Take note of that. The electrical resistance of a resistor is measured in ohms. The symbol of an ohm is the Greek capital omega. In the Greek alphabet, they have the one they call omega. That omega has its sign. So ohm, the symbol of ohm is that omega sign. Okay, in the Greek letters. Okay, the somewhat roundabout of ohm is definition of 1 ohm is the resistance between 2 points where 1 volt of applied potential energy will push 1 ampere of current. Okay, these are the diagrams of a resistor. Now the first one by my left is a metal film resistor. So you can see the labels. Both the colors, the ceramic parts, the end cap, the FZ coating, okay, FZ coating, the metal film, and the LEDs. Okay, these are the components of a resistor, the components of metal film resistor. So look at how it looks like. These colors you are seeing here are very, very important to engineers. It's very, very important to engineers. It is used for identification. It's very, very important. Okay, this resistor in a circuit diagram. A resistor in a circuit diagram. This is symbol how it is represented. I hope you are getting it. In this case, we have 12 volts battery. We have the current passing through 6 ohm. Okay, these are the connections both in parallel and in series. Okay, the units I've told you about that. Units of a resistor. The unit of a resistor is ohm. Okay, or can have ohm for smaller units. We can have kilo ohm for 1000, mega ohms for 1,000,000, and then giga ohms for billion. To make larger values easier to read. Do you understand that? It is very common to see resistors in the kilo ohms and mega ohms range. Much less common to see million ohms. Do you understand that now? Okay, for example, we have 4,700 ohm resistors is equivalent to 4.7 kilo ohms. Do you understand that now? And 5,000, okay, 5,600,000 ohms resistor can be written as 5.6 kilo ohm. Do you understand that now? All right. More commonly as 5.6 million ohms. Do you understand that now? Okay. This is bringing us to the end of the class. All right, the end of the class. We have looked at resistor as a component that checkmates the flow of current or volts into other components of the circuit or even in the entire circuit. Do you understand that now? Okay. Then we say we have two types of resistors. We have the variable, we have the fixed resistors, which changes slightly with change in voltage or current, as the case may be, and then the variable resistor, which are also, which changes, which can be designed or adjusted, to effect changes, especially in the control of volume, in control of lamps, your bulb, the way your bulb is shining, whether it's shining very bright or very dim, they are all as a result of the resistor, variable resistor in them. Okay, so at this juncture, I have to give you the small assignment I have for you. Some of you have not submitted the previous assignments. Okay, the small assignment I have for you here is this, or here. Number 1, explain the following. I resistors in series, I resistors in parallel. So go and find out with your textbook. Resistors connected in series, how does it mean? And resistors connected in parallel, what does it mean? Draw a circuit diagram of 3 resistors and EMF, that's electromotive force, in I parallel. So you draw one for parallel. You must indicate the 3 different resistors, also indicate the source of electromotive force in them. Okay, the second one, and in series. So 3 in parallel and then 3 in series. Number 3, list and explain 5 types of fixed resistors. You may include diagrams. So a resistor, I have told you, we have several types of them. Okay, but in this case now, I just picked fixed resistor. In fixed resistor, we also have different types of fixed resistors. So mention just 5. List and explain 5 types of fixed resistors. You may include diagram to explain better. Okay, thank you for being part of this class. I wish you all the best.